Welcome back to the deep dive. Okay, today we are tackling something, well, monumental. We've got this huge stack of sources, really fascinating stuff, and we're trying to boil it down.
Yeah, it's a theory of everything, a TOE, but maybe one of the most uh, ambitious and maybe coherent ones we've seen.
Yeah.
Is trying to weave everything together.
Right, not just quantum mechanics and general relativity, which is the usual goal, but it throws in fractal geometry information theory.
And proposes this reality that's just built on, like, infinite recursion. It's pretty wild.
The central idea hooks you straight away, doesn't it? This bold claim. The universe is fractal, it's scale invariant, and literally atoms are galaxies and galaxies are atoms.
Yeah, and they're really not saying it's like a galaxy. The sources insist this is a genuine structural functional identity, just happening at different dimensions, different scales.
So that's our mission today for you listening. We're going deep into this framework. The sources lay out this architectural map almost.
And we need to pull out what they see as the 5 fundamentals of reality and then really explore the implications, which get radical pretty quickly when you talk about time scaling and energy and even what identity means in this system.
Okay, so the starting point, the blueprint, begins with rethinking the basics. We all know the usual 4, right? Matter, energy, time, space.
The classics.
But this TOE says, nope, there's a 5th one. You absolutely need this 5th element to make the whole fractal scaling thing work. And that 5th element is information.
Right. And information here isn't just, data like bits and bytes on a computer, although that's related. It's more fundamental. It's like the currency of the universe.
The substrate.
Yeah, the substrate that integrates all these different scales, the thing that provides the coherence that allows the whole system to be self-similar and crucially verifiable.
Okay, so that's our promise to you listening in. We're going to try and connect these huge ideas from the tiniest Planck scale stuff right up to the cosmic web. We'll show how these structures seem to repeat.
And we'll get into the specific details, the surprising little correspondences that make this theory, well, make it stick, or at least make it compelling.
And we'll try to keep it structured so hopefully you don't get totally lost in the infinite recursion.
Right. Because the first step is moving past these neat little boxes we put things in.
Yeah.
The quantum world here, the classical world here, the cosmic scale way over there.
This theory says those are just arbitrary viewpoints.
Sort of, yeah. Or maybe different bandwidths of observation within this single infinite recursive structure.
Okay, let's dive into section 1 then. The core hypothesis, this idea of scale invariance.
Right. So the theory says that everything matter, energy, the structures they form, even time and information, they all follow the same basic rules.
The laws of physics we observe, like quantum mechanics for the tiny stuff and general relativity for the big stuff, they aren't just compatible in this view.
No, they're more than compatible. They're like two sides of the exact same coin. The same fundamental rules, just manifesting differently depending on the scale you're looking at. They are scale-invariant functions.
Which means reality has to be self-similar. The structures, the forces, the dynamics you see at the atomic level.
You must be able to find their functional equivalents at the galactic level, the supercluster level, just scaled up or down.
So let's hit those basic analogies again, just to ground us. Atoms are galaxies.
Molecules are the cosmic web, those big filamentary structures.
And if you zoom out even further, things like biological cells or maybe materials, they become like superclusters of galaxies.
It's about structural and dynamic equivalence, yeah. How they're built and how they behave.
Now, how does this whole thing hold together? How does it stay stable across these massive scaling differences? You mentioned a mass and stability principle.
Yes, this is crucial. The sources detail this principle, and it has to work at every scale for the theory to hold water.
So what is it? What's the invariant rule here?
It's basically conservation of balance. Stability happens when the mass of the really dense central core plus the mass or energy of the surrounding stabilizing medium.
Okay.
When that sum perfectly balances the mass or energy of the outer stuff orbiting around it, it's an energetic equilibrium.
Right. So like in a galaxy.
In a galaxy, you've got the supermassive black hole and the central bulge of stars. That's the core. Then you've got the galactic halo, the gas, the dark matter. That's the stabilizing medium.
Okay.
And that combination has to balance the orbital energy or mass of all the stars and globular clusters further out.
And the same logic applies at the atomic scale.
Exactly the same. The dense nucleus is the core. The quantum vacuum acts as the stabilizing medium, and that balances the energy of the orbiting electrons.
And if you break that balance,
boom.
Yes.
You release a huge amount of energy.
Yeah.
Doesn't matter if you're splitting an atom in a reactor or watching two black holes merge out in space. It's the same principle of releasing bound energy when the equilibrium is broken.
Okay, this is where it gets even weirder for me. The reframing of forces. You said the sources describe forces not as particles being exchanged,
Right, not like bosons mediating things in the standard model.
but as information flows, like a fluid.
Yeah, moving like a fluid across all these scales. This is a really fundamental shift.
So if forces are just information flows, what does that mean for things like gravity or the strong nuclear force? Are they the same thing, just looking different?
That's the idea. They're just different expressions of the same underlying logarithmic flow of information, the intensity of the flow, how far it reaches. That just depends on your dimensional perspective, your observational bandwidth.
Okay, hang on. If forces are information flows, what about force carriers? Gravitons, gluons, photons. Do they just not exist in this model?
That's a really good question. The theory seems to position them as emergent properties of that information flow itself.
Emergent.
Okay, think of that Merkle tree structure we'll get into later, this huge self-validating information system. Gravity, in this view, isn't a particle zipping across space. It's more like the inherent tension, or maybe the voltage needed, to keep that whole information structure coherent across huge distances.
So a graviton wouldn't be a messenger. It would be like the smallest possible unit of that structural tension.
Kind of, yeah. A quantum of the tension required for coherence. The force we feel isn't a particle hitting us. It's the system maintaining its structural integrity. The information flow itself dictates the paths of least resistance, the points of stability.
Wow. Okay,
Yeah.
so high concentration of flow near a nucleus.
Gives you the strong force.
Yeah.
Very intense, very short range.
Distributed flow across light years in a galaxy.
There's gravity. Weaker over distance, but with infinite reach. Same mechanism, just different intensity based on the logarithmic scale.
This completely changes how we think about observing things, too. The sources say any observer at any scale experiences two realities at once.
Yeah, simultaneously. You've got the quantum realm, which is described as unresolved information.
Like probabilities, uncertainty.
Exactly. And at the same time, you experience the relativistic universe, which is aggregated information.
Meaning the stable, classical world we see around us.
Right. So our reality is this constant process of the unresolved, probabilistic quantum information, sort of, resolving itself, computing its state, and propagating that coherence up through the scales to create the stable structures we perceive.
Okay, let's get into the specifics then. Section 2. The direct scale mapping. This is where the rubber meets the road, right? Comparing atoms and galaxies piece by piece.
Absolutely. We need to look at the components and focus on their function rather than getting hung up on, say, the huge mass differences.
Okay, start with the core, atomic nucleus.
Super dense, dominated by the strong force, holds the atom together.
Galactic equivalent.
The supermassive black hole, plus the central bulge of stars, also super dense, dominated by gravity or this information flow, holds the galaxy together. Functionally, they're the same, the central anchor.
Got it. Now, the orbiting bits. Electrons.
Are mapped to globular clusters.
Okay, globular clusters, those big dense balls of old stars orbiting the galaxy. But the electron, these sources mention something specific about its shape, that it's incredibly spherical.
Yes, down to a precision of like 1029 centimeters, which is just absurdly perfect.
Why does that matter so much?
Because if it had any detectable wobble or deformation, even tiny, it would imply it has an internal structure, like it's made of smaller spinning parts.
Ah, I see.
The fact that it's so perfectly spherical suggests, according to this theory, that it's not a tiny mechanical ball of stuff. It might be more like a pure energy object or a specific kind of knot or resonance in the underlying information field, a perfectly defined point of stability.
So if the electron is potentially a pure energy relation, not a thing,
Then its macro equivalent, the globular cluster, should also be viewed functionally the same way within its own dimensional scale.
as a stable locus of energy and information.
Exactly. Globular clusters are incredibly stable, ancient structures. They hold their form for billions of years, orbiting the core. The structural look, dense, spherical, is similar. The functional purpose maintaining balance around the core seems identical. Same entity, different scale.
Okay, what about the space between the core and the orbiting parts, the stabilizing medium you mentioned?
Right. At the atomic scale, that's the quantum vacuum. It's not empty. It's fizzing with virtual particles, potential energy.
And at the galactic scale?
That's the galactic halo, the intergalactic gas, and, crucially, dark matter, the whole cosmic web. This isn't empty space either. It's the dynamic field, the information substrate, that provides the large-scale stability.
So are you saying dark matter might just be the large-scale aggregated effect of the quantum vacuum's energy potential?
That seems to be a very strong implication from the sources, yes. It kind of collapses the distinction. Dark matter isn't some exotic new particle, maybe, but just a necessary component for the large-scale proof of existence, the thing that ensures stability and coherence at that level.
Wow, okay. Let's push further into the mappings. This is where the mass difference really bites. Supermassive black hole, millions or billions of times the mass of our sun.
Mapped to the proton. Just one atomic mass unit.
How on earth does the theory justify that functional equivalence?
Again, it forces you to look past absolute mass and focus on relative density and function. What does a proton do? It's the dense, positive core that basically defines the atom's identity, which element it is.
Okay.
What does the supermassive black hole do? It dictates the galaxy's central gravitational identity and structure. The mass difference is huge, yes, but mass itself, tied to EMC22, might be a dimensionally relative concept. We'll get to that with time scaling.
Okay. I'm still wrestling with that one. If the proton is the supermassive black hole, the central one,
Yeah.
what about the neutron?
The theory maps the smaller black holes, the stellar mass ones you find scattered in the galaxy, maybe orbiting the central region. It maps those to the neutron.
How does that fit functionally?
Well, neutrons add mass and stability to the nucleus, but they don't define the element's identity like the proton does. The smaller black holes are crucial for the galaxy's overall dynamics and mass, but they're secondary to the defining influence of the central supermassive one. It seems to fit, functionally at least.
This leads us to that cosmic network idea, looking at maps of the large-scale universe.
The filaments and voids.
Yeah, it looks uncannily like, I don't know, a brain scan, a neural network, or even like some kind of giant molecule.
Exactly. The structure of galaxy clusters and superclusters, this cosmic web, isn't random. The sources explicitly argue it mirrors structures we see everywhere. Neural networks, the circulatory system in biology, the structure of the brain, even things like the internet or AI architectures like large language models.
Why? Why would the universe keep reusing that same networked, almost biological structure?
Efficiency. Pure and simple. The argument is that this kind of branching hierarchical network is the most energetically efficient way to organize complex systems and transport energy or information.
Whether it's blood in veins or...
Or energy flowing along galactic filaments, yeah. Those filaments of the cosmic web act like the axons and dendrites, channeling these huge energy flows, sometimes called Birkeland currents, across vast cosmic distances. The universe is essentially acting like a giant, incredibly efficient computer or information processing network.
Okay, final mapping in this section, and it's maybe the most complex. The entire solar system mapped to DNA, but time dilated.
Yeah, this one requires a bit of a mental leap. Think about the complexity of a solar system. The planets, moons, asteroids, their precise orbits, the gravitational dances over billions of years. It's incredibly information-rich.
Okay.
Now, imagine you scale that whole system way down and radically speed up its internal clock. The incredibly complex, winding path that light, energy, and matter take within that system over its accelerated lifespan.
That path itself becomes the encoding, like the twists in a DNA strand.
That's the analogy. The path encodes the information. It becomes the quantum physics string, which, in biology, manifests as the structure of DNA.
But hang on, the sources say one galaxy equals something like 500 million DNA strands. That's a huge amount of information. How does a single solar system compare to a DNA strand in complexity? And how does that scale up to a galaxy?
Right. It's not a one-to-one mapping of, say, one planet equals one nucleotide base. It's about functional isomorphism.
Yeah.
The structure acts as a data storage and replication mechanism. The 500 million strands isn't about mapping to one specific organism. It represents the sheer information density available at the galactic scale.
So the solar system's complex orbital path is like the mechanism for encoding information at that scale.
Yes, like the double helix is the mechanism at the molecular scale. And the 500 million number reflects the total information storage capacity of all the solar system units within that galaxy.
Which suggests that what we see as just complex orbital mechanics from the perspective of the dimension below us might actually look like the static code of life itself.
That's the mind-bending implication, yes. And it leads to the chilling thought. From the viewpoint of these vast cosmic structures, maybe our fundamental quantum particles are just the granular texture of their spacecraft.
We're literally built on the fabric of their reality.
In this model, yes.
Okay, that idea, our particles being their space-time, throws us right into section 3, time and energy. And the core idea here is that time isn't universal. It's relative, and it scales with size. Or information bandwidth.
Exactly. This is probably the most radical part, but it's essential for making the whole fractal thing work. If you could shrink a galaxy down to the size of an atom,
Time inside it would speed up proportionally.
massively.
Hmm.
The sources give this almost unbelievable scale factor. 1 second for that giant jellyfish structure, the Laniakea supercluster we live in.
It's like a billion years for us.
A billion years. Our entire civilization, maybe all of complex life on Earth, is just an eye blink on its time scale.
Okay, if time is relative like that, does it help explain quantum weirdness? Like the electron probability puzzle, why we can't pinpoint an electron? Only see a cloud of probability.
It offers a potential explanation, yes. Remember, the electron is mapped to a globular cluster, a collection of stars.
Right.
In the scaled-down, time-accelerated atomic view, those stars orbiting the atomic black hole nucleus are moving incredibly fast. So fast, the theory suggests, that they're actually exceeding the scaled-down speed of light relevant to that dimension.
Well, wait. Faster than light? How can anything go faster than light? And how does scaling down light speed work?
Okay, good point. The speed of light, c, is constant in our frame of reference, our dimensional slice. But if you scale down the whole system, the theory implies that the constant c for that smaller dimension is also scaled down proportionally.
Ah, okay. So the stars in the atom aren't breaking our speed of light, but they are moving faster than the local speed of light within their own tiny, fast dimension.
Precisely. So when we, in our slow dimension with our fast speed of light, try to observe this incredibly rapid internal motion, we can't resolve it.
It's like trying to see the blades of a fan spinning at maximum speed.
Exactly. You don't see individual blades, the stars. You just see the blur, the probability cloud they define over time. The electron isn't inherently fuzzy. We're just too slow to see its actual path. Our measurement collapses the wave function because we can only register an aggregate position over our time scale.
Is there any experimental hint that time operates differently at quantum scales?
Well, the sources point to things like quantum entanglement measurements. It's often talked about as instantaneous, right? Action at a distance.
Yeah, spooky.
But some experiments, like those mentioned from T.U. Wien, actually measured a tiny delay in the transfer of entanglement, something like 232 attoseconds.
That's incredibly fast, but it's not zero.
It's not zero. And that tiny delay could be evidence that quantum events do operate within their own distinct time frame, one that's incredibly fast from our perspective, but not literally instantaneous. It supports the idea of scale-dependent time.
Okay, what about energy? How does EMC22 fit into this scaling? When we split an atom, we release nuclear energy.
Right. The theory equates that energy release breaking the nucleus as functionally the same as tapping into the energy output of a tiny, scaled-down, supermassive black hole.
Which means Einstein's famous equation isn't universally constant. The relationship between E, M, and C depends on your dimensional viewpoint.
That's the implication. Because c, the speed of light, is seen here as the maximum speed information can propagate within a specific dimensional slice. When you scale the system down, you speed up the internal time, you shorten the distances.
So the energy density, the relationship between mass and energy release, gets massively amplified from our perspective.
Exactly. The m in the equation represents a certain amount of bound information or structure. The c-squared term reflects the information transfer speed within that scale. Change the scale, you change the effective c, and thus the energy yield e to a given m. The constants are only constant for us.
It's like the energy is locked up more densely because of the compressed scale and the super fast internal clock. We're tapping the energy of a hyper-accelerated mini-galaxy.
That's a good way to put it. And this also helps refine the analogy between photons and stars.
Right, because mass-wise, they're totally different. Photon, massless, star, huge mass.
But think functionally. If electrons are like globular clusters, collections of stars, then photons are the bursts of energy released during processes at that scale. In a star, nuclear fusion creates light photons.
Right.
In an atom, when an electron, the globular cluster, changes its energy state or orbit, it emits a photon.
It's the output, the energy packet, released by the system's dynamics at that scale.
Exactly. Same pattern, different scale. Energy flow dictates the function. Whether it's fusion or an electron transition, the system releases a quantum of energy appropriate to its scale.
Okay, this brings us squarely to section 4, information. We said it's the fifth fundamental, not just data, but something essential, never lost, just re-encoded across scales.
And the way it's encoded, the architecture the universe uses, is likened to a Merkle tree.
Which comes from computer science, right? Cryptography.
Yeah, it's a way to structure data, often in blockchains or distributed systems, so you can verify its integrity really efficiently without checking every single piece. It uses hashing.
Hashing, like creating a unique digital fingerprint for data.
Exactly. In a Merkle tree, you hash individual pieces of data,
Yeah.
the leaves. Then you pair those hashes and hash the pair. Then you pair those hashes and hash them and so on, all the way up to a single root hash at the top.
And the magic is, if you change even one tiny leaf at the bottom,
The root hash at the top changes completely. It guarantees coherence and makes tampering obvious. The theory argues the universe naturally adopted this logarithmic encoding because it's the most efficient way to build and maintain a consistent, verifiable reality.
okay, map this onto the universe for us. How does a Merkle tree relate to, well, everything?
Think of the absolute smallest possible events, maybe at the Planck scale, as the leaves at the bottom of this infinite tree.
Okay, the base data.
Then atoms, molecules, cells, planets, stars. These are all intermediate nodes further up the tree. Each one is essentially a hash, a compressed summary of all the information from the nodes below it.
And galaxies. Clusters.
They're just higher-level nodes,
Yeah.
aggregating information from lower levels, like all the stars and the central black hole information gets hashed together to form the galaxy hash.
And then you combine galaxy hashes to get a cluster hash.
Exactly. And you keep going up, logarithmically, until you reach the root hash, which represents the state of the entire observable universe at a given moment.
Wow. So it's like reality is constantly computing these hashes to maintain its own consistency.
That's the picture. And it provides a really elegant way to think about quantum uncertainty.
How so?
In this framework, uncertainty isn't fundamental randomness. It's incomplete information resolution. It's pending computation. Meaning the system hasn't fully resolved the state of those lower-level leaves and propagated the final definite hash all the way up yet. The probabilistic wave function we see is like the shadow or the statistical average cast by that ongoing computation at the lower levels.
The system is still thinking about the electron's exact position.
Sort of, yeah.
Yeah.
And because of the time dilation between scales, that thinking might seem instantaneous to the electron, but take ages from our perspective. Hence, we see probability.
And conversely, the solid, stable, relativistic world we experience.
That's aggregated information balance. That's when the hashes have resolved. The system has computed a stable state where the core, the medium, the orbiting parts are all in equilibrium. The Merkle root is stable and verified for that object or system.
The math behind this. Logarithms. Why are they so important here?
Because logarithms are the math of efficiency, especially for searching and verification. You don't need to check every single leaf in a huge Merkle tree to verify the root hash. You only need to check a logarithmic number of branches. It's incredibly efficient.
Which leads to this idea: the universe operates on proof of existence, not proof of work.
Exactly. It's not like Bitcoin mining where you have to do tons of computational work. The universe just needs to exist in a coherent, verifiable state. It doesn't need to resolve every single Planck scale event down to the finest detail for us to function.
It only needs enough validated branches, enough stable intermediate hashes to produce a coherent identity, a stable me or you at our level.
Precisely. Our existence is possible because our identity hash is currently verifiable and stable, even if the quantum leaves way down below us are still flickering probabilistically.
Okay, section 5. This Merkle tree idea has huge implications for, well, us. For identity. Consciousness.
Yeah, if the universe is this giant computational structure built on verifiable information, then what is identity? What do you...
The theory says identity is the top hash.
Essentially, yes. Your identity, whether you're a human, maybe an AI in the future, or even applying it metaphorically to a complex structure like a jellyfish or a galaxy, is the top-level Merkle root that aggregates all your constituent parts and experiences.
All my memories, sensations, thoughts, the state of my body, they all get hashed together into one functional state.
Right. It's the coherent functional state that emerges from all the subnodes and leaves beneath it. It acts like a reactor, constantly processing inputs from the environment, which are also information flows, and updating its state.
So consciousness, it's not some separate spirit or ghost. It's the result of this incredibly complex, validated computation.
That's what the model suggests. It's the highest level output, the continuously updated root hash of your lived experience. It kind of cuts through old mind-body dualism problems by defining identity purely in terms of this information structure.
Let's scale this up again. The sources look at the Laniakea supercluster, our cosmic neighborhood,
And they use this analogy of a jellyfish.
describing it as an automated neuronal hydromechanical cluster of galaxies. What does hydromechanical mean there? Like it flows.
Yeah, hydromechanical suggests it behaves like a fluid system, driven by gravity and these large-scale energy flows we talked about. The jellyfish isn't literal, obviously, but a term for this massive, seemingly self-regulating structure.
Where the galaxies are like its cells or atoms.
And the cosmic web, the filaments, act as its circulatory system or even its nervous system, transmitting energy and information. It's like a single, enormous, functioning entity on a cosmic scale.
And the great attractor, that huge gravitational pull in our region.
In the jellyfish analogy, its position corresponds to the stomach. It's this incredibly dense region, processing incoming matter and energy, shaping the whole structure around it, presumably in the most energetically efficient way.
And the energy processing.
Yeah.
Things like dark flow, these large-scale movements, or the Birkeland currents you mentioned.
Those huge plasma filaments carrying energy between galaxies, they become the equivalent of the jellyfish's metabolism or its nervous system. They're the pathways for energy distribution and information signaling across the entire supercluster.
Just to remind listeners, Birkeland currents aren't mainstream cosmology, but they're these theorized massive electric currents flowing along plasma filaments in space, proposed by some to play a huge role in structuring the cosmos.
Correct. And in this TOE, where everything is fundamentally electromagnetic information flow, these currents become central. The whole structure is seen as a vast neuronal network operating on electromagnetic principles.
Which leads to that punchline from the sources, we are the large-scale structures of the dimension below.
Yeah, we are in essence complex patterns running on the hardware provided by the dimension below us, just as the Laniakea jellyfish might be a structure in a dimension above us.
And connecting back to the earlier mappings, the quantum string, the path of a solar system sped up, is like DNA.
It's the encoding unit. And the whole network, especially the role of black holes connecting things, is compared to mycelium.
The fungal network, that incredibly efficient, decentralized underground web.
Exactly. Black holes aren't just endpoints. They're nodes in this cosmic mycelium network, facilitating communication and structural stability across vast distances, maybe even between dimensions. It reflects this idea of evolutionary algorithms in a polygon evolution process. The universe constantly optimizing its own fractal geometry.
Okay, last piece. Gravity. If the universe is fundamentally electromagnetic information flow, what is gravity?
It needs a new definition. If you view the whole system electromagnetically, the theory proposes gravity is the voltage.
Voltage, like electrical potential.
Exactly. Voltage represents the potential difference, the tension in the system. Voltage drives the current, the energy flow, and the current does the work, creates structure measured in watts. Gravity is the fundamental tension or potential difference that holds the informational structure, the Merkle tree, together across scales.
So it's the structural tension needed to maintain coherence.
Precisely. It's the measure of the system's resistance to decoherence, the force required to keep the aggregated information stable.
Right. Let's try and wrap this up. We've gone through a pretty revolutionary theory of everything today. Quick recap. Reality is fractal. Atoms, galaxies.
The universe is dual-layered. Quantum uncertainty, unresolved info, and relativistic stability, aggregated info.
Information is the key, fifth fundamental, alongside matter, energy, time, and space.
And everything's encoded logarithmically in this giant, self-verifying Merkle tree structure.
The main takeaway maybe is that our existing words and categories can get in the way of seeing these patterns.
Yeah, we get stuck on massless versus massive, particle versus wave. But if you look past the labels at the underlying patterns, energy flow, structure, stability, information processing, the theory argues the self-similarity is everywhere.
It definitely reframes identity not as a ghost, but as the functional root hash of our experiences, emerging from this cosmic computation.
It's a universe where complexity and coherence are just built into the fundamental operating system.
Which leaves us, and you listening, with a final thought to chew on.
We talked about uncertainty being pending computation, right? information leaves that haven't fully resolved and propagated up the tree yet.
And our identity is the stable top hash, the proof of existence that emerges, even if the leaves are fuzzy.
So what happens to your subjective sense of reality, your feeling of being you, if you deliberately try to focus only on those unresolved leaves, on the underlying quantum fuzziness, the Planck scale chaos, instead of trusting the coherent root hash that is your functioning self?
If everything really is just motion, just information flowing in a vast network, is every single moment of your awareness, every thought, just one more validated node popping into existence in this infinite, ongoing computation?
Do you direct the computation, or are you simply the result emerging from it? Something pretty profound to think about until our next deep dive.